Hello, this is Mr. Wynn, and this video is over the unit circle, how to create it and use it. So by now you've noticed angles are very important in trig. They're what we input or plug into a trig function to get some value used for solving. Before we get into unit circle, we got to explain the two ways we define angles. So first, an angle is simply a measure of movement involving rotation from a starting point or side. And the first method of defining angles is using degrees, which have the unit, the degree sign. Alright, so if I start on the right here, the start point, and move to position 1, so this is purple line, I moved or rotated 90 degrees. If I'm at the start and go all the way to position 2, so this red line, that went to 180 degrees. So if you know that in geometry, half circle is 180. If you start here and go to position 3, the green line, that is 270 degrees. Then start and go to position 4, that's 360, a full lap. Right now you can keep going. You can do a full lap and a half. So if you go all the way around and keep going all the way to 2, that is 540 degrees. So if you know every box is 90 degrees, I'll say. And there are degrees in the middle as well. Alright, the second method of defining angles is radians. A radian is just the length of the radius for that circle. Now since different circles have different radii, the value isn't constant, so it has no unit. This is still a type of angle describing movement involving rotations from a starting point or side but intersecting the entire circumference. Think of it as a radius wrapped around. Also remember that a circle has circumference 2 pi r, and if we say pi is 3.14, that means every circle has a circumference of 6.28 radii. So there's 6.828 radiuses that can go around the entire circle. So here it is. We have a radius r. Let's call it 5 inches. That means this length right here is 5 inches. So that's 1 radian, because that's 1 radius. There's 2 radians, or 2 radii, so this would be like 5 and 5 is 10 inches. Here's 3 radii. Now I want half a circle, so here's 3.1416 radians, which is pi, which is 180, half a circle. Alright, in pre-cal and beyond, using radians instead of degrees is the norm. The more you use it, the more comfortable you get, and the more you like it, and a lot of shortcuts and benefits to using radians over degrees. So one of the first things we gotta get used to when using radians is learn how to convert from degrees to radians and vice versa, radians to degrees. And before I'm doing that, let me re-explain dimensional analysis. Dimensional analysis allows you to change between units as long as you're in the correct conversion factor or rate. You'll keep multiplying by fractions, canceling out units until you end up with what you want. Now be careful which way you're the fraction. Here's some simple facts. Y'all know 12 inches is 1 foot, 60 minutes is an hour, 24 hours is a day, 7 days is a week. So question 1, how many feet is 6 inches? So we start 6 inches, I'll put 6 inches on 1. Now I need to get rid of inches. I need inches on bottom, and then I need feet on top. The correct conversion is 12 inches is 1 foot. So I put 12 on bottom, 1 on top. Now I can cross out the inches, because inches cross out inches. So you can do the number separate and the unit separate. Now I just multiply, that's 6 over 12. All we have left is feet, and that reduces to 1/2 foot. So you know 6 inches is half a foot. Let's try a different one. How many inches is 4 feet? We start at 4 feet. I need to get rid of feet, so feet's on bottom, inches on top. So that's why 12 is on top this time and 1's on bottom. Cancel out the units, feet's cross out. 4 times 12 is 48 over 1. We don't need a 1, so 48 inches. So I know 4 feet is 48 inches. How many minutes are there in 2 weeks? We start 2 weeks. Gotta get rid of weeks. So weeks is on bottom. And I know the week to day conversion. That's 7 days for 1 week. Alright, now we get rid of days. So days is on bottom. And I want to turn to hours. So we know there's 24 hours in 1 day. So there's 24 hours on top, 1 day on bottom. And go to hours. And I can turn that to minutes. So we know that there's 60 minutes in 1 hour. Start canceling out all the units. So weeks versus weeks, days versus days, hours versus hours. All left is minutes. You multiply the tops and the bottoms, but the bottoms is 1, so we can do it alone. This is a big number, so use a calculator. There's 20,160 minutes in a whole week, or 2 weeks. Alright, the conversion rate for degrees to radians is 360 degrees is 2 pi radians. Now you could divide both sides by 2 to get the other one. 180 degrees is pi radians, your choice. So convert 240 degrees to radians. So we have degrees. We need to get rid of degrees on bottom. So radians on top. So degrees here, the radians on top. The degrees cross out degrees, and I'm going to reduce 240 divided by 180. That's 60 goes both. 60 goes in 244 times. 60 goes in 183 times. So really that's 4 over 3 pi radians. Here's the reverse. Change 7 over 2 pi radians to degrees. So we're starting with radians. I need to get rid of radians. So radians is on bottom. Degrees is on top. Radians cross out with each other. Pi's cross out with each other. 180 divided 2, it's 90. So 7 times 90 is 63 with a 0, so 630 with the degree sign. Alright, they may ask you to convert negative degrees and negative radians. That is the exact same steps. We'll talk about negative angles later on. Alright, the unit circle is a graph of a circle with a radius of 1 unit. It will have the most important points in pre-cal. It will be used extensively. In a sense, it will be our calculator to help us find the values of almost everything. It will be your best friend. I'll show you how to create a unit circle using our two special right triangles, 45, 40, 90 and 30, 60, 90. But first, we have to redo each of them with the hypotenuse of 1. So here's a 30, 60, 90. If the hypotenuse is 1, you know that's the 2x, right? 2x equals 1, that means x equals 1/2. So we now know our 30-degree measure. If x equals 1/2, we know x root 3 is going to be 1/2 root 3, which is just a root 3 over 2. So we know our 6-degree angle. Here's the 45, 45, 90. We know it's x root 2. So if x root 2 equals 1, I'm going to divide both sides by root 2. So x equals 1 over 2, but you have to rationalize that. Multiply root 2 over root 2 to get root 2 over 2. Now it's 45 over 90, so both of these sides are the same. And this last one is just 36, 90, but I just stood it up. So same thing. So 30 is 1/2, the 60 is root 3 over 2, and then hypotenuse is 1. So when we're creating the unit circle, first we have the 4 points on the axes. The radius is 1, so the distance from the origin to here is going to be 1. So 1, 0 or 0, 1, -1, 0, 0, -1. Then we're going to put our first special right triangle, the 36, 90, and label its XY order pair. So this is the point right here. How far right do we go? We went from 0, 0, went right root 3 over 2, and we went up 1/2. Then we do our next triangle, 45, 90. So how far do we go right? Right root 2 over 2, up root 2 over 2. Then we do our next one, 36, 90, but stood up. We're going right 1/2, up root 3 over 2. Notice all these have radiuses of 1. Alright, so this is what we basically did. Alright, now we're going to reflect or flip our points over the y-axis. We're going to flip these sideways. So the only difference is now the x is negative. So this is left -1/2, up root 3 over 2. This is left root 2 over 2, up root 2 over 2. Left negative root 3 over 2, up 1/2. Then we flip all these points downwards. So now we change the y. So this goes down to make both x, y negative. This goes down to make y negative. This goes down to y negative. This goes down to make the y negative. This is still right, so x is still positive on this side. Alright, now we need to add our angle. So this was 0, this is 30 degrees, 45, 60, 90. Then this was another 30, so this is 90 from here. Then this is 45 more, so that's 9 plus 4 is 135. 9 plus 6 is 150. Then 9 plus 9 is 180, and it just keeps going all the way. Last, we add our radians. You might have to convert the first two times, but here it is 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, and so forth. Alright, now this is a lot of information, but you don't have to memorize everything. You just have to memorize the first quadrant. Everything comes from the first quadrant. Here's some simple tricks or patterns. The x values, as they go from left to right, increase the number from square root 0, square root 1, square root 2, square root 3, square root 4, and it's always over 2 on the denominator, but be sure to reduce. So square root 0 over 2, that's 0 over 2 is 0. Square root of 1 is 1 over 2. Square root 2 can't reduce over 2. Square root 3 over 2, and then square root 4 is 2. 2 over 2 is 1. Same thing for the y is going up. So here's 0, square root 0 over 2, square root 1 over 2, square root 2 over 2, square root 3 over 2, square root 4 over 2. Alright, once you have those points, just flip them, change the signs. For angles, I always do 30s first, always in the middle. So this is 0, 30, skip this, 60, 90, 120, 150, 180, 210, skip this, 240, 270, 300, skip this, 330, 360. Then I fill in those missing 45. So it goes 45, 90, 135, 180, 225, 270, 315, 360. And last, for the radians, I notice the 6s are always close to the x-axis. So here's over 6, close to the bottom. 5 over 6 goes on. Here's over 6, close to the x-axis. Over 6, close to the x-axis. So 1 over 6, 5 over 6, 7 over 6, 11 over 6. The 3s are closest to the y-axis. So here they are, this point, and then this point, this point. Then the 4s are always in the middle. Alright, no fraction can reduce. Alright, so you should be able to recognize that. And then it's well worth your time to practice filling out blank unit circles. Just Google it and fill it out. So now that you know how to create the unit circle, let's figure out how to use it. Notice, because the radius or hypotenuse of every right triangle inside is 1, our trig functions are even easier to use. We simply use the x, y value. So here's an example picture. Alright, we don't know the angle, but we have a radius of 1. And then here's the x value, whatever it is, here's y value. Oh, alright, that's okay. Alright, so notice sine of theta is over h, right? So this would be O, which is y, over h is 1, but y over 1 is y. Cosine is a over h, a is x, h is 1, so this is x. And then same for the rest, you can just flip it. Alright, so now our hypotenuse is 1, basically the denominator doesn't matter, or all the h's don't really matter. Alright, so when using the unit circle, the x value of the coordinate represents the cosine value, the same as adjacent. Y value of the coordinate represents the sine value, which is the same as opposite. Then side note, sometimes the tangent function is written as a sine function divided by cosine. Here's the verification. I change their fractions, fraction divide fraction, fraction multiplies fraction, so it should be the same thing as right here. Alright, so use the unit circle to find the values of each of these. Sine of 120. So 123 is right here. Sine is the y value, so I'm going to use root 3 over 2. Simple check. Cosine of 4 pi over 3. So I'm looking for 4 pi over 3 is right here. Cosine is the x value, so it's going to be adjacent. So it's going to be negative 1/2. That's easy. Tangent 11 pi over 3. 11 pi over 3 is... Oh snap, hold on. That was meant to be 11 pi over 6. 11 pi over 3 is going over the unit circle. We will do that later though. Is right here. Tangent's over a, so y over x. So it's negative 1/2 on top, root 3 over 2 on bottom. I'm going to make it fraction divided by fraction, fraction times fraction, multiply the 2's cross out, it's negative 1 over 3, rationalize that to get negative 3 over 3. Cosecant of 11 pi over 6. Cosecant goes with sine, so instead of O over H, it's H over L. I'm just going to flip it. So let's go to 11 pi over 6. The y value, I'm going to flip this. Instead of negative 1 over 2, it's going to be negative 2 over 1, which of course you fix to negative 2. Alright, secant of 330. 330 is also right here. Secant, it goes with cosine. So instead of a over h, it's h over a. But that, which is the x value. And I'm going to flip this. Instead of root 3 over 2, it's going to be 2 over root 3. You rationalize that to get 2 root 3 over 3. Then cotangent of 315 is right here. Cotangent is opposite of tangent. Instead of over a, which is y over x, it's going to be x over y. So it's going to be root 2 over 2 on top, divided by negative root 2 over 2 on bottom. The same thing divides itself as 1, but it's negative. That's just for the video. Hope you enjoyed it. Make sure you ask any questions. Thanks for watching. See you soon. Bye.